Just like humans, complex arithmetic is hard for large language models. This have been proven even with the number one models like ChatGPT 4. A lot of people have struggled with it to get the LLMs to get the arithmetic right. That is where this new research done by these two researchers from the National University of Singapore is quite interesting. They have proposed a way to fine tune LLMs for arithmetic tasks. They have come up with a new model called as GOAT. Large language models do fairly good at addition and subtraction as well as multiplication and division by single digits or by powers of 10. But when it comes to more challenging tasks of multiplication and division of larger numbers, LLMs struggle. One way to perform these tasks well is to divide them into simpler subtasks. A similar technique exists for division, multiplication, and other tasks. These approaches can enable LLMs to perform more complicated mathematical tasks, and that is where this new project GOAT or LLM, which is a fine-tuned version of LLaMA model, has really shown a lot of promise. If you go into the detail of this paper, this is one example of how LLM does the step-by-step arithmetic. So what these researchers did, they built this GOAT, and GOAT stands for a model good at arithmetic tasks, by fine-tuning LLaMA on a synthetic dataset that comprised 1 million examples of arithmetic operations on integers that were divided into steps for easier calculation. The results were astounding. When authors compared GOAT and GPT-4 on Big Bench, which contains arithmetic operations on integers up to 5 digits, GOAT performed either on par with or better than GPT-4 for all operations. Specifically, GPT-4 struggled to multiply and divide large numbers. Multiplying 5-digit numbers, GPT-4 achieved 0% accuracy, while GOAT achieved 96.7%. Dividing 5-digit numbers, GPT-4 achieved 53.4%, while GOAT achieved 96.5%. GOAT also performed better than other LLMs like Bloom, GPT NeoX, OPT, and Pythia that had been fine-tuned in the similar way. This could be due to the fact that LLaMA generates a separate token for each digit, while the other models learn tokens for multiple digits. Anyway, we all know that LLMs have latent mathematical knowledge that can be unlocked by thoughtful fine-tuning, and that is where this paper has a lot of promise. Another good thing about this paper is that it has a GitHub repo and it gives you some instructions to get this thing installed locally, which is always a good idea because it's always good to try it out locally or in the Colab. So for the purpose of this video, I'm going to use my Google Colab. So let me log in there. This is my Google Colab. Let's first install the prerequisites. There are quite a few like bits and bytes, PEFT for parameter efficient tuning. So let me cancel my other sessions with Colab. So you can see that it is installing a lot of stuffs, including transformers and Gradio for user interface and 10 piece and a lot of other things. And it is almost done. It is installing Fire at the end of the prerequisites. Fire is primarily a Google built Python library which enables you to generate automatically CLIs from any Python object. Okay, so that is done. Now let's move on to the next step. And in the next step, we are just defining a class for the prompter in order to use in the prompt in this template. And then this is the code where all the action happens. Let me walk you through quickly what is happening here. Now, first we are importing some of the usual libraries like operating system, tokenizer, and all that stuff. We are loading it in 8-bit precision because we are using this for Colab. Now we need to change this because this base model is no longer available. So let me go to Hugging Face, grab this new model from here and then replace it here because that is what we need to do. And then we will just keep this GOAT model for LoRa 7B, low rank adaptation, and then we want to run it in the Gradio, so that is what we need. And of course we are using GPU from this Google Colab, so it will quick to select CUDA, not the CPU. And then we are initializing our prompter class, as you can see here, and then we are giving it the LLaMA tokenizer. From there we are downloading the model, and then we are specifying this PEFT from the pre-trained model. Now in this whole code, this code chunk which I have just highlighted is, I believe, the most important one, so I'll just spend a bit of a time here explaining it. So what is happening here is that this is where parameter efficient fine tuning or PEFT technique is being utilized, which is LoRa or low rank adaptation. Now PEFT model from pre-trained is being called with all of these arguments like model, which we have specified above. And then from there, and this model contains base model and all these parameters here. Then we are specifying the LoRa weights. The LoRa weight is specifying the LoRa weight which we defined above. LoRa is a technique for fine-tuning LLMs in a parameter efficient manner by introducing trainable low-rank matrices to the model's attention mechanism. This allows for effective adaptation to new tasks without altering the entire pre-existing weight structure, preserving the general weights of the model while still customizing it for specific needs. So that is what it is all about. And then this is the usual stuff, which is setting the data type for tensors in the model to 16-bit floating point, and device mapping is to our CUDA device or whatever is being used. So that is the most important one. Then we are evaluating it, giving the prompt, and then generating the output with the help of Gradio in the user interface. Let me run it. Now it is going to download the model, hopefully, and then that will take a bit of a time. So let's wait for it to finish and run. There you go. You see that this is downloading the tokenizer, model, weights, and everything. So this might take a bit of a time. It depends upon your download speed. And you can see that it is downloading around 33 shards of it. So second shard is being done. So let's wait for all the shards to be done. So it has so far been able to download all 33 shards. And now it is loading all the checkpoints. Let's hope it is able to do that on my free GPU. If not, then tough luck. It has failed, as you can see here, and I have been fixing a lot of errors in this one. I think they really need to work on their GitHub repo. They shouldn't be posting it if it is not in the working condition. First I thought maybe I will not post this video, but just to in the spirit of my channel where I post all the good and bad and everything. So a good model as far as theory is concerned, but don't rely on this GitHub repo. So really bad experience with this model. And even if you go to this GitHub repo, sorry for flipping around, you will see that they have given the link. Sorry, here, this is where I got the link to this Colab. And even if I go to their Colab, you will see that let it open, that they have mentioned some of the models which are not even this model. It doesn't exist anymore on Hugging Face, and that is why I used the other model. So maybe that is the issue, but this model doesn't exist. So pretty bad for a paper which has been even published, that it is not really up to the mark. That's it. Let me know your thoughts on this. A very, very good idea, must say, because there is a real need for it. So maybe here is a chance for anyone who is looking to fine tune LLaMA or any other model in order to make it more arithmetic friendly. Let me know your thoughts in the comments. If you like the content, then please consider subscribing to the channel. And if you're already subscribed, then please share it among your network, as it helps. Thanks for watching.